Happy Labor Day to everyone. My name is Jacques Lothier, founder of the Singular Numerical Relativity. Today, on the behalf of all the religious, political, and scientific heroes, I would like to present to you this new revelation. It is a scientific revelation, and it comes in the name of the singular numerical relativity. Especially today, I will discuss about the quantum gravity and the unified theory. And in this topic, I would like to answer just two questions. First is why general relativity could not explain the realm of atoms and particles. Second is how to unify general relativity and quantum mechanics. So to begin with, I will be just giving you a brief explanation, but I have prepared notes which are down here. You'll be able to read the notes and everything clearly there. But as the author, I would like to really emphasize on some points that are very important for you to understand at first sight. So why general relativity could not explain the realm of atoms and particles? So to answer to this question, we have to go back to the time when general relativity and quantum mechanics were born. We know that general relativity came ahead of quantum mechanics. This graphic tells us exactly the story about the two theories, what exactly, how they were born in this at that time. And what we are interested in is this portion where we say the point of the missing link. I'm not saying that this is the missing link, but I'm saying the point of the missing link. Why? Because after Einstein formulated his theory of special relativity, he was looking for a way to extend this theory into general relativity. And why? Because the special relativity was just describing the motion of objects in straight lines and at constant speeds. But the real universe doesn't work that way. Therefore, Einstein was looking for a way to introduce acceleration and the geometry of space. And the only way he found is to introduce gravity, or to insert gravity into his theory. And he did it very beautifully. Today we all appreciate it. Those who study general relativity, they really admire so much the work that Einstein did. And it has given us so much in science, in technology. But something went wrong at that point. When he was formulating gravity, he forgot that there was already someone who had prepared the way for him. I mean someone who had already prepared the tools he could use in order to describe gravity for all the levels of the universe. And that person is Galileo. Galileo is the one who discovered first the relationship between space and time. Of course, if you check in the books, Galileo doesn't talk about space. He talks about distance. But what is distance? Distance means space from a point to another. So it means space in one dimension. And Galileo measured and he found out that once an object is in a free fall, the distance it will travel is directly proportional to time squared. Distance equal time squared. These are the findings of Galileo. And he was able to produce a diagram like this. So this diagram tells us a very fundamental story of gravity. If you don't understand it, you just look at the numbers. The numbers are the key for us to understand how exactly gravity works. You have here the line of time. Here is the line of distance. Time is 0, 1, 2, 3, 4, 5. Continue. Then you have distance 0, 1, 4, 9, 16, 25. And this is because the relationship between space and time is a square relationship. But what Einstein was looking for, he was looking for acceleration. Where will we find the acceleration? Look at these numbers in red. During the first unit of time, the object will travel once. During the second, it will travel 3 times. Next, 5 times. Next, 7 times. Next, 9 times. So we can go on 11, 13, all increasing always by 2 times. Why is it so? Because when the object is in a free fall, it has an acceleration. And it is showing us that the speed is increasing all the times. So it is a constant increase of the speed. And that's acceleration. I will not give you the formulas because this is just an introduction I'm giving to you. But there is a formula if you want now to know how this acceleration works. When we study the theory itself, we will be showing you how the acceleration is formulated here. And next, we see these numbers in green. We say that when time is 1, distance is 1 squared. 2, 2 squared. 3, 3 squared. 4, 4 squared. 5, 5 squared. Continue. Is distance expressed in square? No. What it means here? The object is falling and it has a velocity. you see very well, as we saw here, that the speed is increasing all the time. Therefore, this body has a velocity, and it describes around itself a vectorial field. We learned that through general relativity. General relativity explained very well that space and time bend around objects with mass. And this doesn't matter. Mass doesn't matter. It may be the mass of a sun or the mass of the earth, but as long as that object has a mass, it has influence on the space on its trajectory. Therefore, this is what it describes here. To understand this, I would like to take you to the movie house. When you go to watch movie in the cinema, here there is a law that works there. You want to know the size of the image on the screen. You just measure the distance between the projector and the screen. And this gives you the size by simply having this distance squared. So it means the size of the image on the screen is directly proportional to the square of the distance between the projector and the screen. So you have all these numbers. As you see here, the distance is 1 foot. You have 1 square foot. 2 feet, 2 square feet. 3 feet, 3 square feet. So that's the law. And this is called the square law. Then, what is the image? The image is light. Why light follows the same square law described in the experiment of Galileo? It's because light follows the geometry of space. That's general relativity. So, speaking of light, even if you want to know the intensity of light, we have to simply consider the distance. And the intensity of light is inversely proportional to the square of the distance. So, as you leave the source here, the intensity of light starts reducing according to the square of the distance from the source. So, light follows the square law. And speaking of the inverse square law, we have to see this, because this is the origin of that inverse square law. Isaac Newton gave us this formula that says that the force of attraction between two particles is inversely proportional to the square of the distance between the two particles. So this is all to say that the square law is at the center of the description of gravity. So all the theories that deal with gravity must deal with the square law. There is no escape. So, because of that, we need really to emphasize on the square law. However, this square law has a problem. It has a problem. Why? When distance becomes zero, what happens? Following this formula, we have infinity. Infinity is nonsense. Infinity cannot happen. You mean the force of attraction between the sun and the earth together becomes infinite. You take the moon and the earth, infinite. A basketball and the moon, infinite. A tennis ball and infinite. All become infinite. It's not possible. It is not possible. It is inconsistent. So because of that, even here, in the inverse square law of intensity of light, we see the same problem. It can become infinite or zero. Can the source of light be infinite or zero? It's not practical. And that's the problem that we have found. Because of this, all the theories that deal with gravity are affected by a virus we call the interpretation of the square law. So the square law was misinterpreted, to tell you the truth. That's the point. So the reason, if we go back to the beginning, as I said, why general relativity could not explain gravity at the fundamental level, it's simply because of this disease. This is a problem, a big problem in physics. So now we have to choose. Are we going to stay with this problem, continue teaching our children the same thing here, or we have to change this? We have to get the right interpretation. So that's the point. So today I would like to tell you that we have to get the right interpretation of the square law in order to resolve the problem of conflict between quantum mechanics and general relativity. So in the next topic, I will be explaining how we are going to resolve the problem. So, thank you very much.